Welcome back. This is on version 7.7. So I go to manage aerial imagery, and if you remember in video 2A, I uploaded some raw MicaSense 5-channel captures and used OpenDroneMap within ImageBreed to create the orthophotomosaics. That was this December 11th imaging event, and I had selected both Field Trial 1 and Field Trial 2 to be included in that imaging event. And so I can choose to run the standard process on either of these. They're essentially the same. And so here I'll continue. We see a workflow. And then on this step, we select an imaging event band to take through the process. And it's recommended to select a band with high contrast, such as the near infrared. So we have the blue, green, red, near infrared. I'll select the near infrared. If your image happens to be very dark, you can brighten it for the purposes of the standard process. So there's this option. In this step number 3, we can use ground control points to automate the entire standard process. However, you can only use this after you've already completed one imaging event. And so in a future video, I'll explain how to use this. For now, I'll skip it. And here we perform a rotation. I'll zoom out using Control-, and I'll click on this button to draw a grid for assistance. Then by dragging or using the arrow keys on this bar, I can adjust the image so that the vertical lines are even with the field. And then I'll continue to the next step by clicking here. In this step, you need to crop the image to an area of interest. And so I click on 4 corners. And we have this polygon to remove the road and other features, other sections of the image that aren't relevant. And notice I've clicked outside of the ground control points so that they're included in the cropped image. And then I'll go to the next step. So this step number 6, is for thresholding. And thresholding is designed to remove the background from the plants. Here the default is to discard the lowest 25 and the highest 25% of pixels. By clicking here, it's possible to change this threshold. The threshold you can choose to ignore the threshold because the original images are also saved, and phenotypes are also extracted from the original image and the thresholded image. So I'll continue just with the defaults. And this step number 7, is where we actually define the Polygon template. I just wanted to note that you can always move back to a step. Say you needed to adjust the rotation, and so on the workflow, these steps are navigable. So on step 7, first thing I need to specify the number of rows and the number of columns I want to draw. So I'll just say 4 and 5. Then I click to start templating, and it says to click on the top left corner of the area to create a template for. So I'll click OK, and then I'll click on the top left corner of the area of interest. Then it says to click on the top right corner. And then it says to click on the bottom right corner. And finally, click on the bottom left corner. And so, and this is just for demonstration purposes. We see the template is drawn. You can drag the corners of the template to redraw the template. Here I'll okay. So it's possible to drag these corners. It's possible to draw several templates. So say I needed to draw a section that had five rows and 3 columns. So I can again click the corners of the area for that template. So we have two distinct templates. The number of each template has a number, so number 2, number 3, and they're displayed in this table. We have the option here to either remove a given template or to copy paste a given template. So the copy paste works by by clicking on the top left corner of the spot to paste. And so we see pasted template is number 4. And so it's possible to remove it as well. And so again, you can always click here to start over. A feature here is the margins. So if I say I add 15% margin to the top and bottom and 20% margin to the left and the right. So when I draw this template, it has this buffering happening, so that's controllable through the margins. I'll delete that template. If we scroll down to the bottom of the page, we're reminded of the field experiments that are in this image. So we had field trial 1 and we had field trial 2, and these each had 20 plots in them, or the first had 20 and the second had 25. And so this was 5 accessions randomized into 4 blocks. And this one was 5 accessions randomized into 5 blocks. And so we need, the drawn templates should match up to those field experiments, which they do. However, I'll add another template here just for demonstration purposes. And now we have 3 options here. Option 1 is an automatic assignment. So if I expand this, it explains that the plot numbers in the field experiment are paired up with the generated polygon numbers in order. And so the field trials are in order, an order that's defined here. So field trial 1, then field trial 2. And then the plot numbers are in increasing order. So the plot numbers in field trial 1 went from 1 to 20, and then in field trial 2, they went from 1 to 25. So that's how the plot numbers are ordered, and the generated polygon numbers are ordered just as they're drawn. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, there's an additional option here of serpentine versus zigzag. So when the plot numbers are being matched up to the polygon numbers, if you select zigzag, it'll restart on each row. So like 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. Serpentine will allow for a serpentine pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And there's one final feature here, which is you can skip specific polygon numbers. So for instance, if number 15 and 18 and 22 were not planted or not part of the experiment, I can type them in and, one by one and remove them. And actually here, it'll replace them with NA. And so now if I generate the assignments, it says the plots were successfully assigned. And if I scroll back up here, we can, by hovering, we can verify the plot identifiers. And in this case, you see the serpentine pattern. So 11, 15, 16, 17, 18, 19, 20, and so forth. If the automatic assignment is not able to match your experiment, that's what option 2 and 3 are for. And so if I start over here and I recreate some templates, paste this. Right. I can use option 2 and 3 as an alternative to the automatic. And these work the same way. So in option 2, it's a spreadsheet, and in option 3, it's a interactive table. The spreadsheet has 3 columns: so polygon number, plot number, field trial. Actually, it's the same as in the interactive table in option 3. So for this, I'll use a table, and so this works by indicating the plot number that goes in each polygon number. And again, the plot numbers are can be found in these tables down here for each field trial. So 1, 2, 3. And for demonstration purposes, if I wanted to skip number 5, I just leave it blank. And now for field trial 2, I can say skip that one. And then, so when I'm done, I can generate the assignments, and again, scroll back up to view the assignments. Here I should have selected field trial 2 for those. So the spreadsheet is actually much easier to use than this table. But these options allow a lot of flexibility. So I'll restart here and do it one last time. I'll just use 0 margin. Do this one last time. And I'll use the auto assignment for the demo. And so I'll finish. Step 8 just indicates it'll apply the same process to all the spectral bands. In step 9, these are the vegetation indices currently available. So NDVI, NDRE, these will be calculated. And then the final step here is the phenotypes. So the zonal statistics will be extracted, like the mean pixel value, total pixel value, for the vegetation indices and the spectral bands. Here you can change the margins for the area where the phenotype will come from. So the plot image is saved in complete, but these margins are adjustable to kind of zoom in on the area where the phenotype will actually come from. And finally, finish. This will take some time to complete, and we can see the indicator here, processing images in progress. When it's finished, that will go away. And in the following video, I'll show that, so stay tuned and thanks for watching.